Alright, so we're getting into 6.5. That's unit 6.5, and that's drawing transformations. And we have this one right here. That is, we have polygon, quadrilateral, LRTP, and we're going to do a rotation to it, and then we're going to do another one to it. So, first things first is I'm going to figure out L, R, T, P, and I'm going to grab all the points for these. So L is -1 and 0. P is -4 and -1. -1. T is -1 and -3. -3. And R is -1. No, R is 0 and -2. 0 and -2. My algebraic expression for a 180-degree rotation is x comma y, then -x comma -y, if you recall. So if I'm going to make a new set of xy coordinates, I'll do it with red, I guess. Right, so burgundy. Right, so my new xy coordinates in the form of this is going to be -x, -y. Let me see, let's make that bigger so you can actually read it. So xy is going to be -x comma -y. -y. Okay, so the x's and the y's stay in the same location, but they both change sign. Right, so my new x values are going to be 1, 0, 1, and 4. My new y values are going to be 0, 2, 3, and 1. Okay, so I'm going to move this over and I'm going to plot those. So L is going to be 1 and 0. It's my new L prime value. My new R value is going to be 0 and 2. That's my new R prime is 0 and 2. My new T value is 1 and 3. That's my new T prime value. And then my next one is 4 and 1. That's my new P prime. And that should be a refresher from Unit 4. I'm going to use this super sophisticated straight edge to draw all of these interconnecting lines here. And there I have my new quadrilateral from this first transformation. Okay, then the next thing that's going to happen is my quadrilateral, after I apply a dilation of 2 to it. Okay, that pen's almost out of ink. I'm going to use blue. Okay, but little difference here is that it's not by the origin, it's by point L. This is the point of dilation instead of the origin. So it's going to dilate by a point L. So since point L is my point of origin, right, I'm going to multiply everything, or I'm going to expand everything from my point L. Okay, so if I try to expand L from point L, there's no distance from L to point L, from L prime to L, because it is itself. So L double prime is going to be right there at L prime. Okay, I can't expand anything from itself. Okay, but R, okay, I'm going to multiply R by 2 times the distance from L prime. So R prime, double prime, is going to be twice as far from L prime. Okay, so this distance has to double. So how do I figure that out? Well, I have to double the x value distance, and I have to double the y value distance. So this is 1 away on the x value, so it will become 2 distance, and it is 4 away. Sorry, it is 2 in the y value distance, so it will become 4 away. So this will become my double R prime, just like that. Okay, and then I'll just go ahead and expand that. This is my how much that point, that line will expand, right, from there. Okay, and then my t value, it doesn't have any change in x, so the only change in dilation from here will be a change in y. So it is 3 distance from here, and it's going to be multiplied by 2, so that distance is 3, so that distance is going to be multiplied by 2, so it's going to become 6. So t prime is going to be 6. So that's my second points to mark. Just like that. Alright, and then if you can kind of see what I'm doing here, like these points, when I drag them back, they're all going to be centered at my point of dilation. Alright, so P, it is 2, or it's going to be 3 over and 1 up. I have to double each one of those because that's my scale factor, 2 times. So it's going to, it is 3 over 1, 2, 3, or you could be like 2 minus, or 4 minus 1 is 3, so now it's going to be 6 over, so it's going to be 1 plus 6 is 7 for my x value, and then 2 or 1 up, double is going to become 2 up, so now it's going to be here. So this is my p double prime. So now I'm going to expand that line. And then I'll connect these 2 lines here. And there we go. That is my new, there we go, is my dilated quadrilateral after it's all said and done. Right? And you can see here that if I were to mark this and that, they all meet at my point L, right? And if I do a ratio of the length of this to the length of that, it's 2. Length of this to the length of that, it's 2. So the point of dilation being L. Okay? So my next question is, working with limited desk space here, is I have this quadrilateral, and I need to dilate it by a scale factor of 1/2. So x comma y, 1/2 x, 1/2 y. That's my scale factor. And then I'm going to reflect it. So that means that every one of these points, its distance, and it's going to be at the origin. Point O is my point, my distance. Okay, so that means that my distance in both the x direction is divided by 2, or multiplied by the scale factor, which is multiplied by 1/2, or divided by 2. It's the same thing. All right, so my distance from the x axis, and then my distance from the x-axis, and my distance from the y-axis, right? Because the origin is my point of dilation. Okay, so this is actually like the distance from the point of dilation, right? So for both my x value and my y value, it just so happens, because my point of dilation is 0, 0, the points are nice and easy to determine, because it's -2 and 5. Okay, so here we go. So point A, half of that, my x value for point A is 2, so half of that is 1. Okay, and then my y value is 5, so half of that is going to be 2.5. So I'm going to be 1 and 2.5. So I'm right about there for my A prime. Okay, C is my x value is 2, right? So my distance from the origin in the x value is 2, so half of that's going to be 1, right? My x value is 1. Okay, and then my y value is 7, so half of that is going to be it's 3.5. So it's going to be right there, 1 and 3.5. So that's my new C value. Okay, my E value, they're both 3 and 3 for my x and y. So half of 3 is 1.5, so it's going to be 1.5 and 1.5, which is right here. 1.5 in both x and y. That is now my new E prime. And then F is 1 and 1. So both half of that for both x and y is half and half. So that is now F prime. I'll go ahead and connect those dots. I'm blowing on it so it dries and I don't smudge it. There we go. There's 1. There's a 2. Here's a 3. Here is a 4. There is a 4. All right. So there is my dilation. All right. So reflections, super easy to plot reflections across the x axis. Okay, across the x axis. Okay, I don't know why I did that so ugly. I can do it with the straight edge. Okay, so reflection across the x axis. I don't even need to use my algebraic expression, which the end of the algebraic expression is xy, right? And then one of those flop signs, when it flops across the x-axis, all the y's change from either negative or positive, depending on which way it goes. So the y's change, okay? But you don't need to plot numbers in here to figure out what it's going to be, right? The x's stay the same value, and the y's flop signs, right? So A is going to ride this one. It's 1.5, or it's a 2.5, right? Or it starts at what is that? It's 1, I think, is what that was. Yeah, because it was 2. It's going to ride 1, and it's at 2.5. So it's going to ride 1, and it's going to go to 2.5 on this side. That's A double prime. C is 3.5 at 1, right? It's going to ride 1 to negative 3.5. Let's see if you can. There we go. So that's C double prime. E is 1.5, 1.5. It's going to stay 1.5 at X, and it's going to go to negative 1.5 at Y. It's right there. Okay, and then F is negative 0.5 and or 0.5 and 0.5. It's going to stay the X value at 0.5, and then it's just going to ride that to negative 0.5 of the Y value. That's going to be F double prime. That should have been F prime. Okay, so there we go. I have my points, and I can just connect the dots again. And I will have, when I'm done connecting the dots, I will have my reflection across my x-axis. If it was across the y-axis, my y values would have stayed the same, and my x would have changed. Okay, so that is that. Pretty simple, straightforward. All right, moving on to, let me reposition the camera here. Oh, I just turned my light off. Let me turn it back on. Okay, you probably can't even tell. All right, moving on to this one. Okay, I have point O here, and I have this triangle of point O, and I'm going to rotate it counterclockwise about the origin. Let me bring this up a little bit. Okay, so I'm going to rotate this clockwise about the origin. Alright, that's good enough, I think. Alright, so a clockwise rotation is, let's go with blue, x comma y, oh sorry, counterclockwise. Counterclockwise is this way. Alright, so a counterclockwise rotation is, I'm going to leave some space here, is x comma y. And then remember, for 90-degree rotations, my x, my y's and my x swaps. And then for a counterclockwise rotation, the negative sign is in front of my y. Okay. So I'm gonna go ahead and label my QAG. Sure. QAG. And Q is 1, negative 2. A is 5, negative 3. Negative 3. And then G is 2, negative 4. Okay. So my new X, Y coordinates are going to get pulled from the y x, the blue y axis, but then y's are going to be negative. Okay, and they're going to flop positions. So my new x coordinates are going to be the opposite signed y coordinates. So this will be 2, 3, 4, right? Because those are my my y's, and then these are going to be my x's at the same sign. 1, 5, and 2. Should have made those. Whatever. I can keep them. Blue. That's fine. Okay. So Q is 2, 1, 2, 1. That is Q prime. Right. A is 3, 5, 3, 5. Right, that is A prime. And G is 4, 2. 4, 2. That is G prime. It's always easier when you know your algebraic expressions and you use the tables to plot your marks. Wait, that's 4. That's right. 4, 1, 2, 1, 5, 1. Okay. All right. Okay. So that's like a shot suits over 2 and then moves over 1. Suits over 2, moves up 1. That's a good way to check it. Okay, so now this is a reflection across the y-axis. Cool. So I'm gonna shoot across the y-axis here. Reflection is just across like a single axis. It's easy, way easier than across the line x equals 1 or x equals y or x equals negative y. Don't even really need to do a table for that. Right? X comma y equals x, y. The only negative sign is the x, because the x value, the sign changes for x when it crosses the y-axis. But I don't need to make a table as long as I understand what it means. Right? So Q is going to ride the y value to its negative, so its opposite side y value. It started at 2, it's going to go to negative 2. It's going to be Q double prime. This one's G is going to stay at 2. That's the y value, but it's going to shoot over from 4 to negative 4. That's G double prime. And in doing so, they both stay the same distance away from the line of reflection. This one's at 3. It's going to stay at 5, and it's going to shoot over to negative 3. That's going to be a double prime. So when it does all that stuff, it's going to connect all of these things. Now, like I said, if it have a reflection across one of those lines that go diagonally across the coordinate plane, x equals y or x equals negative y, then it makes sense to do the coordinate plane or to do the table. But here, it's easy just to kind of shoot that across. All right. So the next one we have is a clockwise rotation. So a clockwise rotation, x comma y. For a 90-degree rotation, the y's and the x's flop, and one of them changes negative. A clockwise rotation, x is negative. All right. So I'm going to go to this one over here, and I'm going to make a 4-letter, what is this, J, K, L, M. J is 3, negative 1. K is 6, negative 2. L is 5, negative 5. M is 1, negative 2. All right. So my new xy in terms of my blue y negative x. My blue y negative x is going to be as follows. My y's and my x's flop. My x values stay negative or change from change signs. My y's stay the same, but they become my x's. Alright, so negative 1, negative 2, negative 1, negative 2. X's, it's going to be 3, 6, 5, 1, but they all become negative. Okay, so this is going to be a clockwise rotation from here to here, which makes sense because now everything is in quadrant 3 where everything is negative. Alright, so J is negative 1, negative 1, negative 3, and that is J prime. K is negative 2, negative 6, or does K, yeah, J, negative 2, negative 6. Wait, J is negative 3, negative 1. K is negative 2, negative 6. That seems far off. Let me double check something. I think maybe something's wrong there. Negative 1, negative 3. This was 6, negative 2. Oh, that's why, because that's negative 3, negative 1. That's my problem. This is negative 1, negative 3. I'm going to pause it and let my dog in. It's barking. Okay, so we'll go back to this now. Alright, so plotting my points. I just marked negative 1, negative 3, and that is my J prime. Almost made a mistake there, but I think I caught it in time. Alright, now I have, because it just didn't look funny when I plotted my next one, which was my K, which is negative 2, negative 6. They just seem to be too far away. So I almost made a point of marking error. Okay, that's K prime. Then L is negative 1, negative 1, negative 5. L is negative 1, negative 5. That doesn't seem right either. I'll pause it and look at it for a second. Okay, so I just recognize my other error over here. This was negative 5, this was 5, negative 5. So this one should be negative 5, negative 5. Okay, maybe I even said negative 5, 5. I wrote 1. Right, so that's negative 5, negative 5. So this one should be, this one was 5, negative 5. So this one should be negative 5, negative 5. So this one's going to be over here at negative 5, negative 5. It'll be L double prime. Right? Then I have M, which is going to be negative 2 and negative 1. Negative 2 and then negative 1. Negative 2, negative 1. And that's like 2. And that makes sense. That's a good M spot. M prime. Put a double prime here. There should just be a single prime. Alright, now let's connect those dots. I think that looks pretty close. The only suspect is this angle. I think I made that a little steep. I think it's actually from here to here. Yeah, that's better. And from here to here. And from here to here. Okay, I think that looks right. Okay, just kind of shade that in. So this goes over 1, down 2. This goes up 1, over 2. So that's right. Okay, this is over 1, 1 to 3. This is 1 to 3. This is like a 3 to 4. This is a 3 to 4. This is a 3 to 1, and that's a 3 to 1. So that works. So JK, yeah, that works. Yep, L to K, L to K, 1 to 3. Yep, yeah, so all that stuff works. All the slopes are pretty much the same, just kind of rotated. All right, so now I'm looking at a translation here. So every one of these units, all these got to be moved 3 up and 6 to the right. So I'm gonna, instead of like plotting all these and moving them, I'm gonna do this with math. Okay, so I'm gonna do it like this. All right. So my delta x is going to be plus 6. My delta y equals plus 3. All right, so my new x coordinate, my new y coordinate, and it's going to reflect this. All right, so x is going to be 6 minus 1 is 5. My new one for that is going to be 6 minus 2 is 4. 6 minus 5 is 5. And then 6 minus 2 is 4. Y coordinates, that'll be 0. And this will be minus 3. This will be minus 2. And then this will be 2. Okay, so my new m coordinate is going to be 5, 0. Okay, so I'm just going to double check that. X equals 6. Wait a minute. That's 0, 5. 5, 0. So 1, 2, 1, 2, 3, 4, 5, 6. Wait, this is negative 1. Well, that's J coordinate. That's J. Okay, so this is going to be 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3. That is right. Okay, so I can trust my math there. And that is going to be J double prime. Right, then I can do K is going to be is 4, negative 3. 4, negative 3. That's going to be K double prime. Right, and then I can do L is 5, negative 2. 5, negative 2. That doesn't look right. Double prime, and then M is 4, 2. 4, 2. That looks 4, 2. That looks right. This is M. Okay, so what looks wrong? This L is wrong. So 5. So this was negative 5. That's what I think was wrong there. So negative 5 plus 6 is negative 1. I don't know where that came from. So negative 1 minus 2. Negative 1 minus 2 is going to be my new L double prime. Okay, so now I'll link all those together. And there we go, is my new image there. So it shows what it looks like there. Okay. And then we have our last one here. Okay, our last one. What happened to my camera? There's the camera. Okay. So my last one. Move it up so you guys can see it. All right, this is an interesting one. I like this one. This is a translation followed by a dilation, a shrinking dilation. Okay, so I need to fold this paper so it stays in place for me. Maybe move this and focus. Slide it over. All right. So I got a translation here. It might be easier just to kind of do. I'll just do that. So TRS is -7, 2. R is -4, 5, and S is -1, 5. Okay, so translation of x plus 7. So all my x plus 7s, that's going to be 0, that's going to be 3, and that's going to be 6. My y minus 2s, that's going to be 0, that's going to be 3, and that's going to be 3. Okay, so my new t number is going to be 0, 0. That's cool. That is t prime. Right, my new r number is going to be 3, 3. That's r prime. My new s number is going to be 6, 3. This is s prime. All right. So here we go. Do all those three together here. And voila. Now I have that drawn there. Right, now I have a value of 2/3. Draw a triangle as a result of dilation of 2/3. I'm going to presume it's at the origin, and since t, or point t, whatever. All right, so that means that this value is going to be 2/3 of each side. So 2/3 of 3. Let's do it on this. 2/3 times 3 is 2. So each side of these is going to be, my r value is going to be 2, and my x value is going to be 2. So this is going to be my new point r. R double prime. Okay, and my s value is 6. So 2/3 times 6 is 4. That's going to be my new x value. And then 2/3 times 2 is 6. Or is let's see, we had 2/3 times, it was 2. So this is going to be my s y value. So it's right here. Right, so that means that this triangle is now my new 2/3 of, this is my shrunk triangle due to this dilation. Right, and you can see that this line segment divided by this line segment, if I were to do like a calculation of the length of that, it is the same. There's 2/3 the length. This is 2/3 this length. Okay, so that is a long homework assignment. I hope you guys got a lot from that one.